All right, so I want to welcome everyone here to the Kubernetes is hard, but worth it. Here's how to get started for our webinar, part of the Contino CloudFest webinar series that we're doing here. Today's hosts, as we can see, are James Strong, who's Cloud Native Director here at Contino, Gregory Patmore, who's Technical Principal, and myself, Kirk Harbaugh, who's Solutions Principal. If we want to kick it to the next slide. All right, so just a little about Contino to kick off at the top is Contino, we are an enterprise DevOps consultancy. We specialize in helping organizations modernize their ways of working. Here, we really like to embrace a couple concepts, including like cross-functional delivery teams that target reorchestrating their own processes to enable them to build more cloud-native applications and leverage data platforms, right? Focusing in on the teams and enabling them. This enables the teams to enable their business to deliver differentiated services to their customers, right? We like to operate on a global scale. We do have 5 different global offices that span with 400 plus people here at Contino. And we are potentially one of the most referenceable organizations in the world when it comes to all things DevOps, public cloud, cloud native computing, and data adoption. The organizations we typically work with specialize in regulated fields, right? These include verticals in the financial services sector, telecommunications sector, and healthcare sectors. But we also typically work with some other of the world's largest enterprises to help them modernize their software delivery life cycles. These include Allianz, Barclays, Adidas, Verizon, and NSW Transport in Australia. So digging into a little of the background on the and introductions on who we have here today. If we can go, myself, Kirk Harbaugh, I'm a solutions principal here with Contino, and I'll be helping in the facilitation moderator role here, helping with all the questions and the flow of today's activities, which specializes on the next two gentlemen.
Hey guys, name is James Strong. I'm Cloud Native Director here at Contino. I almost forgot where I work for, Kurt. So what that means is I help out with cloud native architectures from the delivery teams. I help talk to clients, and I get to do things like this. So talk to people in webinars and give talks. So it's lots of fun.
And I'm Gregory Patmore. I've worked for Contino for a few years now as a technical principal. I run the delivery teams, talk with the customers, design solutions to meet their business needs, and do more things like this, teaching people, lots of pairing, and really spreading the word about good software and DevOps.
All right, thanks, Greg.
All right, fantastic. So just a little understanding how we're going to kind of proceed through this to help everyone get on a similar level and set some of the expectations on the flow. We're trying to target a panel discussion on the topic of Kubernetes between our panelists today. We do have the chat box that is live and useful for communicating back and forth in the group. I think we've already seen that. The audience is muted all the way through. Questions can be captured in the question block, and I know some people have already started putting them through. The questions that we can in line during the event answer, we'll be pushing those out, but we'll also be capturing these questions to pose to the panelists at the conclusion of the session. Today's session is recorded, and we'll be able to connect on a little bit more of that information of where to find it down the road near the end of this presentation and panel. But with that, I want to offer up the stage to our two panelists, Greg and James, and let the good times roll.
All right, thanks, Kurt. So today our webinar is going to cover getting started with Kubernetes. We're going to start with laying the foundations for good practices. We're going to talk about cluster setups, security and operations, like I said, best practices, securing containers, because that's a big concern nowadays, and then optimizing application development in the Kubernetes environment. Now, we're here to offer information and we're here to offer help, and that's what we're here for. One of the first things we ask clients a lot, though, is why Kubernetes? What problem are you trying to solve? A lot of the times we'll have clients think that everyone else is doing Kubernetes, so I have to. but we have to take a step back and understand what are the business problems you're trying to solve by moving to Kubernetes. We ask them certain questions like, what's the traffic look like for your applications? Is your team even familiar with containerized applications? Because that's the first step. Kubernetes is a container orchestration. And what type of scale are we looking at? Greg, do you have anything to add?
Yeah, really, Kubernetes isn't something you just want to jump into. You got to make sure all your ducks are in the row and that you have probably broader support than just your specific product team or just your operations team in order to make it work. There's a lot of moving pieces, and without the support and collaboration between the various skill sets in your organization, it gets tougher and tougher. But if you can get everybody in line, this technology can really, really help you accelerate.
Yeah, I completely agree there, Greg. So with that, now we're going to go with Kubernetes. Let's talk about some of the best practices. So here's our agenda for the day. We're going to cover containers, obviously, since this is a containerized workload, some of the best practices around that, what workload basics should look like, logistics, so how do we get containers around, how do we get applications from the desktop out into production, cluster setups, what admins should be looking at when they're setting up clusters, integrating security into the pipeline, what your operating environment should look like from a developer's laptop to what production should look like. And then, of course, the developer experience, because this is a new tool, you have to have a really good onboarding experience. Otherwise, people aren't going to want to use Kubernetes, and they'll blame Kubernetes on that. So we always want to make sure that we would talk about the developer experience when using it. So we're going to start with containers because, like I said, Kubernetes is a container orchestration tool. Containers are the molecules of our workload, and getting them right up front can help mean the difference between success and lots of setbacks. One of the first things we try to talk about is minimal container OS. The container image should be as small as possible. The purpose is that you are reducing the attack surface, you're reducing the size. So reduction of size also means that it can get where it's going faster because these things are stored in registries. We've got several options up there. So it's Alpine, Debian Slim, AWS just released their container OS Bottle Rocket. And of course, you can always come with a custom one. Also, the host OS should be as minimal as possible to run a containerized workload. You've got specific examples from Red Hat with their acquisition of CoreOS. Rancher has their own that they brought out with Rancher OS. Ubuntu and VMware even also offers their own. Again, minimize the attack surface. It should only be running containerized workloads. You shouldn't be running other types of workloads on those OSs. So it should be specialized and optimized for running containers. One of the big things that we see a lot when we're working with clients is that they are trying to run multiple processes. They're taking everything that was running on their VMs and they're shoving it into a container and saying that they've containerized the workload. But you want one process per container. And if you're thinking of running systemd in Docker, you're probably doing it wrong. Containers are for process isolation, so you should be only running the application process in a single container. We're going to talk later on about augmenting containers with sidecars so that you can have other options, other functionality. So you're not building in agents into your container image. When you're running your containers, you want to run with a local user. Don't use root. That is a given. Your containers should not be running as root as an application owner. You want to run as an app user. That app user should be created in the Docker file and mapped to a service account that has specific RBAC requirements. So you can, again, constraining the attack surface, you're constraining what the container can do and only what it needs to do. So doing all of these will help with that. You want to write logs to standard out and the standard error. You want to use log managers like Logstash, FluentD, and Splunk. Again, like this allows you to just focus on what the application is doing. How the logs should be pushed off the container and pushed off the host. You only want them to be able to run containers and allow another system. You want to decentralize that problem and allow other systems to manage the logs for your containers. When we're talking about containers and being able to run them, we talk about immutability. You should be able to run that same container image from dev to stage to QA and prod. And well, everyone's like, well, what about my database connections? What about all my passwords and secrets? One of the ways that we can do that is leveraging environment variables and startup options to help differentiate application behaviors. There are lots of templating tools out there that will help you with that. There's Contino, GOM template, console template, and this helps from a developer experience perspective because then you can bake all of that. You don't have to bake all of that into your container image so that you have a different one dev stage, and then you don't know what's running where and when. To continue along that path, you can use environment variables and configuration files. You want to be, again, you want to be diligent in separating out environmental concerns from those needing to run the application. If you change a variable in an app config and it's baked into the image, you'll have different images across the environment. You'll have image sprawl. It's really hard to maintain. You want to pull that app config out of an application and the container. If you're placing it in a configuration and a config mount, it's much more an efficient use because then you just have different configuration files per environment, per instantiation of the image in the application. So we talked a lot about the images. I'm gonna let Greg just stop and see if Greg has anything that he wants to add, and if not, we're gonna go ahead and go into the container build process. Did I miss anything there, Greg?
Nah, just you can't understate the magic of config maps in Kubernetes and leveraging those instead of trying to bake things into a config file inside your image. There's just incredible advantages. In fact, you can, if your application is ready to handle it, you can actually change a config map live on a running container and it will update inside the live running container. You don't have to redeploy it. So if you design your application correctly, you can actually integrate many elegant and advanced behaviors and using just that technique.
Yeah, I completely agree. Actually, we got a really good question here. Somebody asked about sys hardened versions of slimmed OSs. We're going to talk about sys benchmarking and hardening images and applications in the security section. So, but as far as out of the box versions, I don't think so. I think that's still part of things that you need to do as an end user. But we'll talk more about that and having base containers and all of that later on. So we want to automate the build process. So all of those things that we just talked about, environment configs, minimal OSs, updates, sys hardening, all of those things should be treated like we treat software applications. I'm making an assumption there that everyone has a CI/CD process and an automated build process for their applications. If they're doing that, they should also be doing the same thing with their container builds. It should be injected into the process. And with that, since containers are software and they're software defined now, we should also be versioning them as well. You want to invest in a version strategy. Simplest one that everyone's very familiar with is semantic versioning. You want to, this is why I'm inject opinions, is the container versions, the image versions should match the software versions. It just makes it simpler from a developer's perspective. If I'm looking at a running container and I can see what version the container is running, I know what versions the software is running. It should also match with tagging. So this all gets built into the automated build process, the release strategy. So it's really helpful from that. You can also inject lots of metadata into it, via the Docker file. Kubernetes will allow you to inject metadata, specific things like builds, the versions, things like that. So you definitely want to have a strategy built into the process around that. And the dreaded latest tag, you definitely don't want to be using the latest tag. It is not a good practice. One of the issues that you'll see if you use the latest tag is when you're pulling an image or you have an image restart or you have a container restart, it will pull it can pull the latest image based on configuration options. That's getting really deep. But what will happen is it can pull the latest image, and somebody can update that underneath you, and you have no idea what you're running now. So that's why we talk about using the semantic versioning. You know exactly what version you're running, and if you want to get really pedantic, you can go all the way down to running container digests. Again, as part of the build process and part of this adoption, you want to establish a base container to help reduce build times. They can be based off of the specific minimal OSs that we talked about earlier, or you can build your own. The idea around a base container is, if 80% of your applications that you're running in enterprise are running Java and are built with Maven and all of these other things that are required for your application builds, why have every development team have their own Java versions? So you can have, as an enterprise or as an organization, this is the golden image. And this also follows into when we talk about security, blast images, and making sure that everything is secured and there's no CVEs. So it's helpful from that perspective. It also, again, reduces build times. And you can do things like with Golang, you can do on builds, you have multi-stage builds. Again, so it helps reduce the sizes of the images. So there's lots of things that can help when you're using and creating base containers.
I would add one thing to that is, even if you have one team that's doing only one thing, it still makes sense to do a base container, because if you have to go through a bunch of testing or image scanning, you can get a lot of that out of the way outside of your actual feature build process, so that when you're testing and you're running through your features and making sure everything's good, you don't have to additionally test all of the things that updated in your base container, which saves a huge amount of time, especially if you have a security team that makes you jump through a couple hoops before you can deploy.
Exactly. Yeah, it helps reduce that. Using that Docker cache will help reduce build times as well. Good point. Thanks, Greg. And of course, as part of this build process, you always want to be testing and making sure that the changes that you're introducing into the container, into the environment, aren't having noticeable differences on latency, build times. There are specific points that you want to measure, one of them being build time or image size. So if someone from one image to the next, it explodes and it's now, instead of 50 megs, it's 5 gigs, that's a discussion point. So you want to be able to track these things inside your build process. Greg, I'll go ahead and hand it off to you to talk about workloads.
Workloads, awesome. So workloads are, the basic, the smallest business value that you can really deploy out for a Kubernetes, application. There are some basics that we'll go through. Let me just get there in my notes, sorry. You always want to use higher level objects. Now, there's a number of different native types inside Kubernetes, like pods and replica sets. And in the beginning, we used those. We would deploy bare pods and replica sets, but it sucked because it didn't really do everything that you needed it to do. And it was, more akin to still managing a bare metal server or an EC2 instance rather than a containerized workload. So you want to use the stateful sets. You want to use the deployment objects that have the higher level behaviors that you need, like rollout strategies, like scaling features and stuff like that. But should never be deploying a bare pod. In fact, Kubernetes now, when you used to be able to, say run nginx blah blah blah, and it would set you up a pod, but they changed it now and it comes up as a deployment, which runs a replica set underneath. So we still have access under the hood, but we should be using these higher level objects that make our life easier.
Absolutely agree.
Before we move on though, good pod specs are essential for any sort of sleep that you want to have when you run your Kubernetes cluster. You want to make sure that you're setting your CPU and memory. Pay extra attention to your liveness and readiness checks, because that orchestrates how your application comes up, how pods get replaced, and how the Kubernetes system itself understands when your pods and your application isn't running very well. That's all. Keep going to the next one. Sidecars. This is probably my favorite thing about Kubernetes. For me, it's what makes Kubernetes fun. You need a logging utility and you don't have one in your application container, sidecar. You need metrics agent, sidecar. You want to make a bad container act politely, and that application developer is a jerk and doesn't want to work with you, sidecars. Basically what you can do is sort of, this is a great way to separate the concerns within your application. You can have your, let's say you have a Java application, you have that basic Java application running in the foreground on your container, and then all of a sudden your manager says, hey, I just got this great deal from Datadog, or even better, Sysdig, and now we have to throw this in. We need it everywhere. Instead of having to break open your containers and rewriting, adding a bunch of layers to embed the agent, running more than one process inside your container, what you can do is just say, screw you, I'm using a sidecar. And you can bake that agent into the sidecar. You mount the directories that it's interested in from your application container into that sidecar, and Bob's your uncle. You instantly have something that embeds the monitoring. And then all of a sudden, say you did Sysdig, and then Joe, the manager, comes up to you and says, hey, we need this by tomorrow, but we're switching to Datadog. If you have it in a sidecar, all you got to do is make that one little sidecar for the Datadog and swap it out for the Sysdig, or vice versa. It's super helpful. But you should think of these things in the Kubernetes world. You should start to be thinking more like Dr. Frankenstein. Like, I have all these small parts. Now I put them together for something useful. Next slide. Jobs, cron jobs. Not my favorite feature about Kubernetes, but it's super helpful. And if you've got all your workloads normalized across Kubernetes, and everybody's still throwing Helm charts and all their applications are running on Kubernetes, first of all, congratulations. That's really hard to do. Secondly, you probably want to start baking more of these cross-cutting concerns and ETLs and such into Kubernetes as well, so everything's in the same place. But you should think of this as more of a cron jobs as a service, not necessarily the cron tab service that you know. You always want to make sure your starting deadline seconds, you always want to set that, or else you start spinning and you're leaking containers on your cluster, and you probably won't know right away, but there'll be a bunch of space starting to get used up on your cluster. But you should remember, they do take up, these are not magical, no resource sort of applications. When you're running a job, it does take resources. So when you're planning out your clusters, you have to account for how much CPU, memory, IO, all those kind of things that a cron job will use. And if it runs very frequently, maybe you want to consider just creating a container that runs this job whenever it should, rather than using the cron job service, just to raise the visibility of this from the cluster administration perspective. And be sure to remember that your cron job needs to handle its own state if you need a state in your jobs. Kubes doesn't care if you overwrite or erase things that you shouldn't. So if your jobs overlap because you misconfigured them, things can get really, really wonky. So make sure that you put a little extra love into your cron scripts, so that it understands whether it's been run in such a time or if something else is actually running already. That's good for me on that one. Now, logistics. So, we've talked a lot about the basics and the sort of molecules and atomic pieces that we need to run application workloads on Kubernetes. Let's talk about the logistics. How do we manage all of these teams, workloads, and deployments in a sane and reliable way? Now, I come from more of an operations background, so a lot of these will be sort of ops oriented, but James, if you have any other insights, just hop right in and say it.
No,
So the
I
build
completely agree.
pipeline, yeah. So the build pipelines, right? The reason we have build pipelines is so that we have visibility into what's going on during our deployment process. We have some forensic information to troubleshoot from. We have easy ways to see what's going on in the cluster so that we don't have to execute that step, so you don't create knowledge islands on our team where, hey, Bob's the only guy that can run these scripts. I don't know which order they are. If you automate it, everybody will know, everybody will have visibility, everybody can troubleshoot, and everybody can take part in remediating any of those defects. And again, Dr. Frankenstein applies here as well. You want to make small pieces that can be Frankenstein together. So you have a separate pipeline for builds, and then you have a separate pipeline for pulling that build from your artifact repository and pushing it out into your environment. Then you coordinate them together and you have an end-to-end pipeline that builds and deploys. But having those autonomous pieces will pay dividends for you in the end, because things can and will change. And the more you can encapsulate the different pieces of your functionality, is the easier it will be when somebody from on high comes and tries to throw you a curveball.
Yeah, I think
Greg, kind of your strategy for helping risk management on the complexity as you scale this out, right?
Mm-hmm. Yeah, I didn't think of that until I became a consultant. Mostly it was like, oh, I'm working on this cool thing, and Bob, the manager, I hate him. He keeps coming and telling me to do all this other stuff. So I just make these little pieces and I make a framework that they can just plug them in, and he's super happy, and I can move on and concentrate to the things that are important to me.
the thing I really like about build pipelines is it codifies everything that's needed for a team to run and build their applications. It gets rid of that tribal knowledge issue that, like you said, only one person knows how to do this specific piece, and it helps bring a new developer up to speed very quickly.
Yeah, and it also will sort of really go a long way to encourage collaboration. If you work within a organization that might have some silos that they haven't been able to get rid of yet, having automation, having those autonomous pieces really aids in that collaboration, because it's a place another team can come, really take a look at what you're doing, get an understanding of it, rather than trying to talk them through it on a whiteboard every time at the beginning of a meeting. Change control. Change control is easy as long as nothing changes, right? Everybody's change control, you deploy once and you're never going to change it. Your change control is great. But obviously things change all the time. I often see these people, these very large corporations trying to build these systems like to be good at hitting a fastball and trying to force all their products and stuff to be a fastball, but that's just not the way things work in real life. In real life, all technology is curveballs. So they come in a rudimentary or a very manual change control process, and then we just let the devs deploy what they need. That does not last very long. If you have any sort of critical application running in Kubernetes, that will not last long. Changes to scale, application behavior, architecture, footprint need to be communicated well ahead of time. And that's not like 15 minutes before you deploy. You have to communicate that stuff in either a change log or a release meeting or release notes long enough ahead of time for somebody to actually do something about it if something needs to be changed. Don't run up till your deploy date, throw it over the fence and say, hey, it was ops problem, right? You need to collaborate early and often so that you can understand what's going to happen when I deploy this, right? Are we going to need more nodes? Is the rollout strategy going to overwhelm the resources that I have? Do I have enough nodes out there to do a blue-green deployment for this application? These are things that other teams need to know, whether it's your team needs to know it or somebody that you depend on to roll out your application. I recommend practicing this, drilling this. You should be able to rebuild every single thing from scratch. And I try to do that with the teams that I work with as often as every sprint. And sometimes we did it every day. I just can't, impart upon you just the importance of practicing, because you get up at 3 o'clock in the morning, something's going down. If you don't have that sort of muscle memory, and if you don't understand or have the technical assets in place to build things from scratch again, you're gonna have a long night. And so practice and automation pays dividends. Got the hint yet? Automation.
It also helps out with the next part too.
Absolutely, deployment. You're going to want to make sure that your team, your cross-functional team of everybody that it takes to deploy your application, has a good checklist to make sure everybody's done everything they need to do in order to go ahead and deploy the application. Have your testing being done? Do you have sign off on your scans? Have any host updates also been run through compliance and security? Have you updated what finance needs to know about increases in footprint or higher costs due to leveraging another service that you hadn't been before? And don't forget to account for the Kubes resources, right? So if you have a stable workload, you had 10 workloads, 10 application workloads are on it for a year, and then all of a sudden they dump 10 more on you. You're going to need to make sure that you have that extra space in etcd, you have the extra overhead on the nodes themselves, and those kind of things. Also, enough space for the controllers and all the stuff that Kubernetes uses for its own overhead. And again, get the hint, automate. Use something like Helm to package your applications and deploy them effectively. Again, that's another way to codify all these things. Like James was saying, have this stuff in a repo. It shouldn't be a secret. Everybody should have access to it. You should make sure that you spend time with the other teams so that they have at least a basic understanding of what your team contributes to the deployment process. And try to normalize as much as you can that deployment process across all of your different environments. You shouldn't have to use Jenkins on dev and then Circle CI or GitHub CI on production, right? You should make that the same across everywhere so that you're just promoting a qualified piece of software across your different environments and not new processes and new artifacts through each environment. You're going to end up with a lot of exit defects that way.
Yep, completely agree. So we've talked about containers, building containers, a lot of automation that I think Greg has said it's going to be a theme. You'll see that. And we're going to talk a little bit now about cluster setup. So when we're talking about the cluster setup, we want to talk about the basic workload, and that's the node. On nodes, we've talked already a little bit about minimal OSs, but we also want to enable auto upgrades. We want these running in node pools so that you can pull out specific chunks of your cluster, upgrade them, and pull them back in, and slowly start to do a scaled rollout, a blue-green. So it's very controlled, and you can understand how it affects the environment. You want to definitely configure log rotations like we've talked about. You want those logs to be shipped off the node. You don't want any, especially when you're working in cloud environments. VM's a little bit more stable when you're on-prem, but any information that helps with debugging, troubleshooting, security incidents, you don't want that information being left on the node. So you want log rotations, and you want to monitor and set up liveliness on those OS specific environments. And then there's specific things from a Kubernetes perspective. There's agents, volume support, plugins, and there's also a really nice tool that they put out for end-to-end testing. So that once you've set up a node and you've set up a cluster, you can run validations and making sure that the node's up and running properly. And of course, you have the master nodes running the API server, etcd if you're doing that, and the scheduler, all of the other important pieces that make up the Kubernetes service. So you want to make sure that it's load balanced. The master API should be load balanced so that you can run it in HA. You shouldn't, absolutely in a production environment, you should not be running with just one master server. And then when you, as you're rolling through this and you're doing upgrades, this again, this is an opinion. I think Greg's more about doing in-place upgrades. Me, I'm more of a spin up a new cluster with new versions. It's all net new, and then migrate applications over. Because if you've automated the process, you've automated the build, you've automated the deployment. If someone gives you a new cluster, it's an environment variable to point to a new cluster and deploy the applications and test and then fail over. So you want to be able, you want to update the master nodes if you're doing an in-place upgrade. Did I don't want to speak too much for you, Greg.
No, for the record though, I completely agree with you that using a different cluster is the best idea. It's just often not the most feasible solution in a lot of places. But if you can make it more clusters, if you can, if you're fully in the cloud, there's almost no reason why you can't. But if you can make a new cluster and then blue-green over, do it, please. That would be so much better. But some people can't really handle DNS flips, or if you're using on-prem clusters, there's not probably a limited number of resources for you to do that.
Definitely, yeah. When you're setting up a cluster, you want to make sure as a cluster admin that you're enabling and using a CNI that enables network policies, because you want to set up network isolation. This goes into, starts talking a little bit about multi-tenant clusters that we had a question for that I saw from Liam. As a cluster admin and you're setting up a multi-tenant cluster, absolutely should be using network policies, and those are set up per namespaces. We're going to talk a little bit more too about namespaces and a little bit more isolation, and set those up when you're setting up a namespace and you're provisioning a namespace for an application team or an environment. One of my practices is a default deny, because default denies force developers and application owners to understand how their applications talk out to the network and set up the network policy so that they only allow the traffic that should be talking to the applications.
Storage. Storage is a big, one of your top 4 components that you're going to have to deal with, aside from compute resources and networking and load balancing sort of considerations. When you're working on the cloud, you got to make sure it's flexible. Please don't partition your disks in the cloud. It'll make it much harder to resize. We want to steer away from using LVM in the cloud as much as possible. And the way you can resize those disks in the cloud makes that possible. But if you are on-prem, I do suggest you use a logical volume mapping utility so that you can add on storage as you need it. Because there's nothing worse than running out of storage space and being down for an hour while you mount a new disk, format it, and then drag all the data over. In Kubernetes, they provide storage plugins for persistent volumes. These plugins have different capabilities depending upon the providers that you're using or where you're deploying these disks. For on-prem solutions, volumes can be backed by technologies such as Ceph and Gluster, and if you absolutely have to, NFS. In the cloud, for multi-mount solutions, which is super helpful to keep track of session storage or some sort of a data piece that is more of like a file retrieve. If you can't use S3 and you need it to be super fast and have a bunch of things right into it, you can use EFS or multi-mount volumes. But you gotta be careful. You need to handle the collisions by yourself. Running into write collisions is gonna, if you're running session stores on EFS, is gonna really get messy quickly. You have to, consider using your own locking mechanisms. And be sure you understand how your volumes are provisioned across multiple AZs in the cloud, right? You know, there's at least back in the day on AWS, we used to be able to say, hey, I need a persistent volume, especially if you're doing stateful sets, but it would bring up the application pod in one AZ and the storage would be in another AZ and it wouldn't work. And it was really hard to figure that out after, but then I had to move and stop using automated created PVCs and had to create some volumes ahead of time. So make sure you understand the behavior. And again, the best way to do this is to practice, experiment, try it out.
Awesome, thanks, Greg. From the API's perspective, there are several things that we should set up. Authorization, access, and authentication are a big part of setting this up. You want to integrate that with SAML or OpenID. Connect, you want to disable anonymous authentication. You should be able to track who did what, when, and where, and why in a cluster. And there's some admission controls to enable. You want to always enable pull images. So that ensures that the old images and layers that might have cached credentials or other cached information in them aren't used by other applications or old ones. You want to deny escalating exec. So what that does is that even if a pod is running with specialized permissions, you can't also add a sidecar or add in a script that tries to escalate its permissions to more than what it's allowed to do. That admission controller will allow you to deny that. And then, of course, setting up pod security policies. That is a little bit going away with things like OPA that's coming out. But again, you want to have fine-grained control on the authorization of what your pods can and can't do. And of course, everything should be communicating over TLS. I think that's one of the first things you do when you're doing Kubernetes the hard way, or you're looking at rolling your own, is setting up certificates. Now we talked a lot about the cluster setup. Admins will be doing a lot of that, but this also will talk about when we are going into what developers should be doing when they're working with the cluster admins. So with namespaces, you want to set up namespaces. This helps answer one of the questions we had around multi-tenant clusters. So what a namespace will do, it's a virtual slice of the cluster, and it's for workload isolations. You want to set up a schema on how you create those namespaces. So application teams, dev, some kind of way to identify what that workload is doing inside that namespace. And they should also have different RBAC privileges. So a developer in one namespace shouldn't be able to deploy their application in another development team's namespace. Those things like that. So that helps with, again, that multi-tenant cluster piece. So if you only have one large cluster, everyone's deploying to the same cluster with namespaces, it helps with that isolation. You also want to set up different quotas for cluster resources. We'll talk a little bit more about that later as well. Oh, it's in the next slide. So with namespace quotas, what you can do is you can set up CPU and memory. Even you can go so far as to how many volume mounts they're allowed to have, or how many config maps, number of API objects. So that helps with, again, multi-tenant and noisy neighbors, because you don't want one application just coming in and, like the cron job example that Greg gave earlier, and just running over and taking over the cluster. So that will help with that perspective. You can enable quotas by default on namespaces. You can also set up defaults, reasonable defaults, that if they don't provide them as an application owner, they will get assigned to them. And then as a developer, you want to enable those requests and results in the pod spec so that again, this is another helpful perspective, that if somebody introduces a memory leak, per se, in the build process, and in a new build continuously keeps dying because it's running out of memory, this is one of the ways that it can help identify that. Also, you can see that you have spikes in requests and things like that. It also helps into the autoscaler as well. So there's lots of reasons to enable quotas and set up limits and requests.
Learned that one the hard way, trying to
Oh yeah,
deploy Kafka as a stateful set.
yeah. When you can't figure out why your pods keep crashing and running out of memory, and
Yep,
it's a
because
pain.
you didn't set a limit.
So
Yeah,
would
please.
you say the complexity of setting that up is worth it and it works and that's a preferred way to go through it?
It's not even that
Absolutely.
complex.
It's yeah, it's a couple lines in the pod spec. So if you know you're running a Java application and you need to, even if you're using newer versions of Java, they are also container aware. So they can set the memory limits to what the container is allowed to have. So it helps. It's 2 or 3 lines in the pod spec. Probably should have had examples on some of these things. So that's good to know for
We
next
got a
time students
repo.
on that group. Yeah, yeah, we do.
Yeah, we didn't mention that before, did we? There's a repo.
Got that. There's always a GitHub repo. It's at the
Yeah.
end. All right, Greg.
Yeah, monitoring. So now you got this thing up there. How do we figure out what's going on? How do we know when something bad happens or something good happens? And how do we get that to the information to the people that really need to have it? So what I'm going to go through real quick as we're getting close to the end of time. What are you most interested in monitoring? Obviously, your network usage, deployment events, scaling events, pod failures, request times, etcd space. Trust me, you really want to have a handle on how much space and processing power etcd is using and has access to. Node capacity, security, compliance, those kind of things are pretty no-brainer, right? There's a bunch of tools off the shelf to use if you want to engage a commercial product. You have Datadog, Logic Monitor, Twistlock. Definitely recommend looking into Sysdig after yesterday. And then you have utilities like Splunk and stuff like that. Open source, obviously, you always have your command line interface. The command line tools are great for Kubernetes. There's a lot of, you can see pretty much anything using some kind of a kubectl command. Prometheus, obviously, is a very popular monitoring tool for Kubernetes. You also have the basic Kubernetes dashboard, C-Advisor. You can use Elk, Grafana, those kind of things. If I get a little micro machine, sorry.
Well,
Next one,
monitoring is
Peter.
important.
Yes, very important. Spend the time up front. Next slide.
Did it not commit? There we go. Oh,
One back.
one too many. Sorry, Greg.
Yeah, that's it. Cool. Upgrading. Let's talk about resources. You need resources, compute resources, storage resources to run these application workloads. How do you sort of manage those things? Here's some of the most useful tips that I've had running Kubernetes in production. Always upgrade your Kubernetes version on a non-production, non-needed cluster first. Please, always do it. You should never try, because some of these things happen wonky, and then sometimes if you're on a cloud platform, the rollout process for those upgrades can act a bit differently than what the Kubernetes core documentation suggests. Also, it would be pretty good if you need to upgrade a production cluster to run a load on your test cluster when you're upgrading, so that you can understand what's going to happen to your applications and such as you're upgrading. And remember to account for your Kubernetes overhead. My personal formula is to reserve 30 to 40% of an instance's resources for Kubernetes overhead. Now, maybe that's a little bit too much, maybe it's not enough. That's where I say you start and then take some measurements and adjust accordingly. Especially in the beginning. Later you can optimize. Node pools, and this is a really big shout out to that guy that asked, I can't see who it was, that asked the multi-tenant issue, question. You want to use node tools for multi-tenant workloads, especially ones that are completely unrelated. Like if you're running, completely disparate systems on the same Kubernetes cluster, I would almost, put a line in the sand for my job to say, hey, we're going to put this new application on its own node pool, not in the generalized node pool. A lot of people have a misconception with Kubernetes that you just throw nodes in an auto-scaling group and everything's good and we'll just find it. If we need another node, we just let it scale up. Almost never a very effective way to manage Kubernetes. You want to start isolating things in node pools and policies, like James was saying, in order to understand what their behavior is going to be like. And then once you have a reasonable grip on that, you can start to combine those multi-tenant applications into a single node pool if it's good, if it's a good thing to do so. Having things will also make deployments and upgrades much easier to do. Truncate that one a little bit, but if you have any more questions about those, hit me up.
Awesome, thanks, Craig.
Yep.
So we talk a little bit about auto scaling. Those options are available. You have the cluster auto scaler, which helps adjust the size of the Kubernetes cluster, and then the horizontal pod scaler, that's on CPU based. And then there's also lots of things that the Kubernetes API tracks in itself. So there's memory pressure, disk pressure, things like that. So those are things that should also be monitored as well. And then you have to play around with the numbers around that from that perspective. And then, as always, it's really funny. Security is always an afterthought. We've got a couple high-level tasks that we talked about already from like a network policy perspective, isolation, and RBAC.
You want to move that slide up to where you're talking about?
Break in. Just want to make sure the slides are moving through.
Huh.
We're now in containers.
Okay. Yeah, they were advancing for me, but not for everyone else. I'm gonna do a high level real quick, the secure pipeline, because I want to do a shout out to some of the other things that we're doing. You want to use tools that have signed images. You want to verify trusted images and maintain your own registries. There's lots of tools that are out there. I think we've already mentioned a couple of them with like Twistlock, Aquasec, and Sysdig. There's some open source ones as well. And you always want to be scanning containers for vulnerabilities continuously on new builds, and even when you're running containers in production, you should be always managing and watching what those containers are doing and the syscalls that they're executing. That goes along into the operating environment that we talked about. I think the big one there that I want to make sure that we mention is you shouldn't be running multiple types of workloads on these instances. You shouldn't. You should have specific instances for running containerized workloads that goes to the minimal OS. And then there's tools out there that like companies like Aquasec put out for Kubebench. And then there's the sys benchmarking that we can talk that sys benchmarking, which allows you to say if you're running hardened images and hardened container images as well. We talked about network policies from a developer's perspective. I think the big thing here that I want to make sure we mention is examples. It helps to have examples for new developers. That's part of the developer experience piece. And I think, due to time, we're going to have this presentation out for everyone. I think the thing that I wanted to mention for our next one, here it is. So we have all of these best practices out there in a GitHub repository. There's Greg and mine's contact. And then as part of CloudFest, we have our next one that's coming up is boost your applications with an SRE approach to development. One of my coworkers, another TP, Carlos, is going to be talking about that perspective. And if you're interested more in what we have to talk about with Kubernetes, we're also doing an introduction to Kubernetes dojo on Thursday, May 7th. We're running our first one in the UK since we're a global company, and we'll be looking to run those in the States and Australia as well. So apologize that we had to cut off security. It's always an afterthought and the developer experience, but those definitely should be integrated into your adoption of Kubernetes and your best practices. And we'll make sure that everyone has those. With that, I think we got most of the questions. The one I saw was the sys hardening. And
we had two more that we can maybe jump into, James, and I can intro them. The first one is coming from Ryan, and starting out in being a beginner in all of this. Is there a level of understanding recommended before starting to play with Helm charts, right? They seem to have a decent layer of abstraction from the manifest kube control level. Just looking for some background on that.
I would say Helm is a templating engine, really, when you get down to it. You still have to understand what a deployment is, what your pod specs look like, why what your memory and limits requests are. So you still have to understand what those Kubernetes API objects are, and then Helm just helps you templatize those. So I would say still have a base understanding of the API objects and how you're deploying your application.
Yeah.
Craig?
Like I would suggest that you start engaging in Helm once you need to do something with somebody else. Once you start collaborating with other people to produce software and manage it, that's when you start to look for your templating engines. But you don't have to do it with Helm. Like I've been very successful in the past with just a GitHub repo and Ansible
Bash.
playbook.
Yeah, Bash, Ansible, Helm.
Awesome.
Hope that
And
answers
then
your question.
for the question coming through, looking for some of the links, there will be a follow-up to this as well. So the presentation, the recording, these links, more information will be going on. But we have a last question coming in. Thoughts on pipeline technology choices and whether there is a preference for something like Brigade Tecton. I'll pass that.
I didn't catch that last one. I mean, I'm a big fan of GitLab CI. I just spent 4 months on a project with that. It's got really good integrations. A lot of the tools we talked about and the container security piece. They have their own registry inside the project, inside the repos. So, but I started using Jenkins like probably most of the other DevOps engineers on here.
Mm-hmm. Yeah, Jenkins will be one of your easier technologies to get the green light to adopt in your organization because it comes with very little investment up front to get started with it. But to me, I'm a consultant, so I try not to pick my favorites. It's like whatever the client's got, I jump in there and that's what I'm using. So, it starts to become more of the same.
I mean, I'm usually happy when they have a CI/CD process in general.
Yeah.
I think we've got a couple other questions, but we're out of time. We'll make sure we get those answered, and we'll get those questions to you, David. So I want to thank everybody for joining. It's been great, and we'll have this up on YouTube for you guys to view later on as well.
Great questions, guys. Though. Thanks.
Excellent. Thank you.
There we go.